This is Dr.Senthil Kumar, Associate Professor, Department of EEE, SNS College of Technology. We are sailing the subject Power, Electronics and Drives for the third year, fifth semester. The last video series, I have discussed about the Thyristor converter fed DC drive one quadrant operation in terms of animation. And now let me see the calculation part of one quadrant drive and the operation of two quadrant drive in this video lecture. The circuit diagram of single phase one quadrant drive is here. This circuit, the operation of the circuit and the waveforms have been discussed in the previous video. It consists of two thyristors and two diodes. The input is AC supply and the output is DC, which is given to the armature of a DC shunt motor. You mean armature voltage control technique. Armature voltage control techniques. The calculation part, let the input voltage AC is 230 volt RMS. For calculating a one quadrant drive, you mean single phase semi converter, the output voltage V0 is expressed as Vm by pi into 1 plus cos alpha, where Vm is the maximum voltage of the 230 volt AC and alpha is the firing angle of the thyristors T1 and T2 respectively. So, if alpha is 170 degree, we have seen the animation part in the previous video. If alpha is 170 degree, then the voltage, output voltage is Vm by pi, you mean 230 voltage RMS is calculated for the maximum voltage by pi, such that the output voltage V0 is 61 voltage. It is lesser voltage. The input is 230 whereas the output is 61 DC. It is lesser voltage, therefore the speed of the fan motor is less. See here, if the alpha is 90 degree, you mean the alpha is 90 degree, almost a quarter cycle is the output waveform, then the voltage is half of the input, you mean 103 voltage, almost half, 103 voltage. It is greater than the above, therefore the speed is more. And if the alpha is 10 degree, the output waveform is almost full semicircle, and hence the output voltage is again higher. It is almost 204, almost full voltage, therefore the speed of the motor is higher, which means that if greater the firing angle, the lesser the armature voltage and lesser the speed of the machine. Now let me see the single phase two quadrant drive. In the previous video, we have discussed about the operation of one quadrant drive. It consists of two diodes and two thyristors. Whereas here, since it is two quadrant, normally a full wave controlled rectifier comes into picture. See here. The circuit diagram consists of four thyristors, you mean full wave controlled rectifier. Both the positive off cycle and the negative off cycle is controlled one. The input is Vs AC voltage and the output is V0 DC voltage, which is given to the armature. Here it is a shunt motor. A field winding is shown here where uncontrolled DC supply is given. The circuit diagram of full controlled rectifier in two quadrant operation, two quadrant drive. The input and output waveforms, which is already been discussed in the two quadrant operation of a full controlled converter. Therefore, let me see the calculation part alone. Let the input voltage, again it is AC 220 voltage RMS. This is AC supply voltage to the converter where 4 thyristors are there. Therefore, with the help of 4 thyristors, this 220 voltage AC RMS is converted into DC. The output voltage formula is 2 Vm by pi into cos alpha. This is the output voltage of the converter which is given to the armature. You mean DC output to the armature. The alpha is the firing angle. Vm is your maximum voltage of AC. You know how to calculate the maximum voltage from the RMS. Now the back EMF, since we have to calculate the speed of the machine, we know that for a DC machine the back EMF EB equal to V minus IARA. Here instead of V I have written as V0 because the output voltage of converter is given to the armature. Therefore, V0 minus IARA. And the speed N equal to EB by phi. EB is your back EMF and phi is the flux in the winding, in the shunt winding. Almost the flux in the shunt winding is constant. Let me assume that the flux is 0.2 Webers and IA is 150 amperes and RA is 0.06 ohms. I am repeating that if flux is 0.5 Webers, IA is 150 amperes and RA is 0.05 ohms, then if the alpha is 30 degree, you mean alpha is from 0 to 90 degree. The output voltage V0 is calculated as 172 volt. The back EMF as per the formula is calculated as 163 volt. IA is 150 amperes and RA is 0.05 ohms. And N is equal to 815 RPM. It is positive, the RPM is positive. Therefore, let me assume that it is forward motoring. You mean the first quadrant operation. Now, if the alpha is greater than 90 degree and lesser than 180 degree, we are assuming that alpha is 160 degree, then the output voltage is calculated as minus 186 volt. You mean 2 Vm by pi into cos alpha. Alpha is 160 degree. And EB is calculated as minus 195 volt. As per the formula, EB is equal to V0 minus IA into RA. IA is 150 amperes and RA is 0.05 ohms. And the speed is minus 975 RPM. Minus 975 RPM. See the speed, the direction of speed is negative, which means that it is reverse motoring. Therefore, this is a two quadrant operation. The first quadrant is forward motoring. The speed is 815 RPM. And if the alpha is 90 to 180 degree, then the speed is minus 975, which means that it is the fourth quadrant operation. 1 and 4 comes into picture. Quadrant 1 and 4. Two quadrant operation is there. Speed is forward motoring in alpha is 90 degree and speed is reverse motoring when the alpha is more than 90 and lesser than 180 degree. See the firing angle is between 0 to 90 and the speed is positive, it is forward motoring. The firing angle is between 90 to 180 degrees, speed is negative, it is reverse motoring. You mean two quadrant operation. See here the calculation part. We are assuming that the IA is 150 amperes, RA is 0.06 ohms and the flux is 0.2 Webers. The quadrant of operation is mentioned here. It is quadrant 1 and quadrant 4. The quadrant 1, the speed is positive, and the quadrant 4, the speed is negative, whereas for both the quadrant, the torque is positive. You mean forward motoring and reverse motoring. Both are motoring, therefore the torque is positive. I am repeating, both is motoring, quadrant 1 and 4, therefore the torque is positive. Whereas the speed is positive for Q1 and negative for Q4. With this, we are understanding that for two quadrant operation, for this circuit, the forward motoring and reverse motoring comes into picture for a motor. There is no braking system since quadrant 2 and quadrant 3 is absent here. Only motoring, forward and reverse motoring operation. Thank you for patient listening. Thank you.